Good day, engineers! So ngayon nandito tayo ulit sa part 3 nung discussion natin on the shear strength of soil. So again, this is Engineer Rodolfo and this is for the course Foundation Engineering. So start natin yung discussion. Una nating i-discuss is yung Consolidated Drained Test or CD test, and another term is slow test. So yung test is kinakonduct on two stages. So, sa first stage, yung consolidation. So, as you can see in this diagram, yung inlet pipe natin bukas and pinapapasok nga yung hydraulic pressure papunta dun sa soil, which will be the minimum principal stress or the chamber confining pressure dun sa soil natin. So, i-consolidate niya yan. So, ibig sabihin, since nandun yung part from the word na consolidated, so i-consolidate niya yan, ibig sabihin, yung outlet pipe natin bukas on the first stage. Kasi nga, consolidation is the escape of water dun sa soil natin. So, palalabasin natin yung tubig dun sa soil natin. On the second stage, i-apply na natin yung delta sigma, which is i-increase natin ng i-increase hanggang yung soil natin dito mag-fail. So, from this part, nakalagay drained. Ibig sabihin, habang naglalagay tayo ng delta sigma, the outlet pipe is still open. So, lagay tayo ng lagay ng delta sigma hanggang ma-reach niya yung level of failure. So, kaya siya tinawag na slow test. Kasi masyadong matagal yung pagde-drain natin ng water. As you can see, from the first part, we will have a change of pore water pressure na delta U, which is equal to 0. And on the second stage, which is yung nagdadagdag na tayo ng deviator stress or yung additional load on the top of the soil, meron pa rin tayong change in pore water pressure na 0. So, kaya siya tinawag na slow test kasi we will drain water on the soil itself. So, if we will plot these stresses on our Mohr-Coulomb failure diagram, so as you can see, ang una nating mapaplot dyan is yung sigma 3, which is the first point on our Mohr circle. Then, mapaplot din natin si delta sigma, which is the deviator stress. Now, pag pinag-add mo yung dalawa na yan, yung point na mapoproduce is the maximum principal stress, which is the second point of our Mohr circle. Now, the goal is to find the angle of internal friction, the cohesion, the angle of the failure plane, and the stresses at the failure plane. So, magagawa lang natin yun using this Mohr-Coulomb failure diagram. And we just assume, since wala pa naman tayong ibang given, we just assume na yung soil na tinest natin is cohesionless or non-cohesive. So it means, from this point, pwede tayong mag-create ng different triangles on our Mohr circle. So, syempre, ipa-plot din natin si angle of internal friction, which is yung angle nung column failure line or nung Mohr envelope dun sa horizontal axis. Then, yung point of tangency ni Mohr circle at ni column failure line, yan yung stresses at failure. Now, we can draw radius from the center of the circle, which is this one, which is point A, papunta dun sa point B, which is the stresses at failure. So, ito radius to. Then, we can also draw from point D or the minimum principal stress hanggang dun sa point B na stresses at failure ng isang line na magko-correspond sa rupture line, failure line, or the plane. So, yung angle na mapuproduce nun from the horizontal is tatawagin nating theta, which is the angle of the failure plane. And sabi ko nga kanina, if we will draw an axis like this on our point of tangency or dun sa stresses at failure, makakaproduce tayo using the radius AB ng angle na phi din. Kasi nga, since ito phi din, so ibig sabihin alternating angles to. So this is alpha, let's say. So yung susunod na angle niya will be phi din. So para lang din siyang kapag itong axis na to ini-rotate natin at an angle phi. So ito yung lalabas. This will be P. So as you can see, we will have different triangles na pwede nating gamitin para makuha yung mga shear strength parameters ng soil. So the first one will be, kunin natin yung triangle OAB. So ang first goal natin is to find the angle of internal friction. Kasi nga, hindi naman tayo makakakuha ng stresses at failure kung unknown si angle of internal friction. So to get angle of internal friction, we will get the triangle OBA. So as you can see from triangle OBA, we will have the delta sigma over 2, which is the radius of the circle. Kasi nga, etong line na to delta sigma. So this is the diameter. Kalahatiin mo yan, yan yung radius niya, which is delta sigma over 2. Now, etong point na to from O to D, that is sigma 3. So ito yan. Then, syempre yung D to A is still a radius of the Mohr circle. So ibig sabihin that is also delta sigma over 2. Now, paano naging right triangle yan? Or nagkaroon ng right angle doon? Kasi sabi natin sa mathematics, kapag nag-draw or sa analytic geometry, kapag nag-draw ka ng radius from the center of the circle, tapos papunta dun sa point of tangency at yung tangent line, ay magkokos ng 90-degree angle. So, yun yung principle galing sa geometry na kinuha natin. Kaya nagkaroon ng right angle dito. So, syempre, ito si phi. So, meron tayong pwedeng magamit na trigonometric function since this will be the opposite and since etong side na to is opposite ng right angle, so siya si hypotenuse. So, that will be opposite divided by the hypotenuse. So, that will be a sine function. So, we will have an equation. Sine phi is equal to delta sigma over 2 divided by sigma 3 plus delta sigma over 2. Then, we will get the inverse sign of the quotient of this one. So, that will be phi is equal to sine of negative 1 or inverse sine of delta sigma over 2 divided by sigma 3 plus delta sigma over 2. Ito ngayon yung pwede natin gamitin equation to get the value of the angle of internal friction. So ngayon, since meron na tayong nakuhang angle of internal friction, pwede natin ngayon ma-solve yung stresses at failure using yung triangle ABC. So we get the triangle ABC from the Mohr circle. We will have this diagram. So, as you can see, from triangle ABC, yung length AB, yun yung radius ng circle natin, which correspond to delta sigma over 2. Delta sigma over 2 siya kasi yung diameter ng Mohr circle natin is corresponding to a value delta sigma. So, ibig sabihin, kakalatiin lang natin yun, that will be delta sigma divided by 2. So, now, etong height niya, which is BC, is the shear stress. Kasi, eto nga naman, pinaplat natin from the principle ng Mohr circle, pinaplat natin on the vertical axis yung shear stresses. So, ibig sabihin, itong height na to will correspond to the shear stress. Pero, yung horizontal length na CA is hindi natin siya pwedeng tawaging sigma. Bakit? Kasi sa Mohr circle, ang sigma is distance from this vertical axis or the y-axis to this point. So, ibig sabihin, hindi siya yung sigma na hinahanap natin. So, we noted it as x sub 1. So, from this figure, we can see na ito yung phi. So, ibig sabihin, if we will use the sine function, that will be x sub 1 over delta sigma over 2. Pero, since ang unknown natin, or yung hinahanap natin is shear stress, we will just use the cosine function since that is an adjacent side divided by the hypotenuse. So, getting the cosine function, we will have cosine of phi is equal to tau divided by delta sigma over 2. Ngayon, ang hinahanap kasi natin si tau. So, we can arrange this term. So, i-multiply natin si delta sigma over 2 kay cosine phi. So, we will now have tau is equal to delta sigma over 2 cosine of phi. Ngayon, ito na yung equation from our triangle na makukuha para mapalabas natin si shear stress. So, this is just by using trigonometry. Now, pwede na natin ngayon kunin si x sub 1. It's either we can use the sine function, sine phi is equal to delta sigma or x sub 1 divided by delta sigma over 2. So, yan ngayon yung pwede din natin gamitin, or we can use the Pythagorean theorem, which is x sub 1 is equal to square root of delta sigma over 2 squared minus tau squared. So, it's either of the two equations yung pwede natin gamitin para mapalabas yung gusto natin na x sub 1. Ngayon, since meron na tayong x sub 1 dito, looking back on the Mohr-Coulomb failure diagram, which is this one, ang goal natin is kunin yung stress at failure, which is this sigma. So, para makuha natin yung sigma na yan, as you can see, meron tayong line OA. So, yung line OA na yun will correspond to sigma 3 plus the radius of the circle, which is sigma 3 plus delta sigma over 2. Ngayon, nakapaloob din sa kanya yung CA, which is x sub 1. So, para mapalabas natin si sigma, so mula dito, since ito yung point ni sigma, ito, so kailangan natin ibawas mula dun sa sigma 3 plus delta sigma over 2, which is ito, yung x sub 1, which is the CA. So, ibig sabihin, parang ganito. So, mula dyan, buburahin lang natin yung CA para mapalabas na natin yung hinahanap na sigma. So, from that one, we will have an equation, sigma 3 or sigma, yung sigma failure na hinahanap natin is equal to yung sigma 3 plus delta sigma over 2. Ngayon, ibabawas natin yung length CA or yung x sub 1 para mapalabas yung normal stress natin. So, yan ngayon yung stresses at failure. Diyan lang natin nakuha using the triangles and the principle of trigonometry. Ngayon, paano naman natin makukuha yung theta or yung angle of the failure plane? So, kung makikita nyo, etong theta na to, kasi this theta runs from here sa line na to, and this is the horizontal stress. So, as you can see, kung yan yung may angle na theta, meron siyang i-intercept na arc dun sa circle, which is ito. At kung mapapansin din natin, itong angle na to, palitan natin ng green. So, itong angle na to, which is the central angle, is eto din yung i-intercept na arc. So, that means, kung ang notation dito ay theta, ibig sabihin, kapag nandun na siya sa central angle, the notation is 2 theta. So, from that principle, makikita natin na kung meron kang 2 theta dito, we can get a value of this angle which is alpha. Ngayon, coming from that alpha, syempre meron ka ng phi dito. So, ibig sabihin, mapapalabas din natin yung theta gamit tong provisions na to. So, kung ito ay alpha at part siya ng triangle ABC, which is ang interior angles ng triangle ay 180 degrees. So, ibig sabihin, that is 90, kasi 90 degree yung isang angle dito, then ito alpha. So, that is 90 plus phi plus alpha. So, si alpha yung kailangan natin. So, we could have alpha is equal to 180 minus 90 minus phi. Then, using this alpha, now, meron tayo ditong angle na to, which will correspond also to 180 degrees. So, that is 180 is equal to 2 theta plus alpha. So, ang kailangan na natin dito is si theta. So, we could have 2 theta is equal to 180 minus alpha. So, si theta yung kailangan natin. So, that is theta is equal to 180 minus alpha over 2. So, using those principles lang, makukuha natin yung mga hinahanap nating theta, theta, phi, and stresses at failure. So, those are the points na makikita natin dun sa pinaplot nating Mohr circle on a consolidated drain test. And by the way, take note also, ang question na kailan mo malalaman na cohesive or cohesionless yung soil. So, automatic kapag sinabi sa problem na ang soil niya is sand or normally consolidated, that is cohesionless. So, meaning C is equal to 0. Then, kapag over consolidated yung soil or sinabi na agad na clay, that is cohesive. So, yung C niya greater than 0. So, that will be the concept for the consolidated drained and kung paano malalaman kung cohesive or cohesionless yung soil. Now we proceed dun sa consolidated undrained test or the CU test or the quick test. So, sa first stage, consolidation pa rin kasi nandun pa rin yung word na consolidated. So, ibig sabihin, consolidation pa rin yung mangyayari. Ang gagawin is open yung inlet pipe, magpapasok ng hydraulic pressure or all-around pressure dun sa soil natin. Since consolidation, open yung outlet pipe, then ilalabas yung tubig dun sa soil using the hydraulic pressure. Then on the second stage, since undrained, habang naglalagay tayo ng delta sigma dun sa soil natin, hanggang antayin natin mag-failure. So yung outlet pipe, as you can see, is closed. So kung close yung outlet pipe, ibig sabihin habang nagdadagdag tayo ng pressure doon, wala nang nade-drain na tubig dito. So nagkakaroon na ng change in pore water pressure. So kaya meron na siyang delta U dyan. So kung i-compare natin to sa CD test, so tawag sa kanya slow test. Ito quick test kasi we don't need to wait for the water to drain. Automatic kino-close natin yung outlet pipe at wala nang nade-drain na water doon. Inaantay na lang natin siya mag-fail. At alam natin na pag medyo basang-basa na yung tubig or basang-basa na yung tubig is nagfe-fail na yan agad. So ngayon, ano yung pinagkaiba na niya sa CD test using the Mohr-Coulomb failure diagram? As you can see, yung broken line dito, which is ito, that correspond to a CD test or the consolidated drained. Then, ano yung pinagkaiba nilang dalawa? Ito si consolidated undrained. So, baguhin lang natin. Gawin ko siyang green. So, this is the consolidated undrained. So, as you can see, shinif nung pore water pressure yung minimum principal stresses niya. So, nag-shift siya papuntang pakanan. So, from consolidated drained na red line, mag-shift siya from the green line or the green circle by using delta U or the pore water pressure and still having the same delta sigma. So, isa pang pinagkaiba nilang dalawa is kung mapapansin nyo, mas malaki yung angle of internal friction ni consolidated drained kesa kay consolidated undrained. So, isang ibig sabihin lang nun that phi or angle of internal friction of consolidated drained is greater than the angle of internal friction ng consolidated undrained. So that will be all for the first two types of triaxial shear test. So on our next episode, we will be discussing the other type of triaxial shear test. Again, this is Engineer Rodolfo, and thank you for watching Butch TV.